Hey, welcome back to your favorite pre-calc class. This is section 1.4 circles. We're going to write the standard form in the course of a circle. We're going to graph one and work with the general form as well. So let's start off here taking a look at the standard form of the equation of a circle. Here you've got the standard form, and your HK, if you notice, is the center of that circle. Let me get my pen here. Okay, so your HK is the center, so that's the HK that'll go in. You notice your radius, the distance from the center out to a point on the circle. Your radius is the R there, which is going to be squared. So here's a very famous circle. This is called the unit circle, which you'll study more of in trigonometry, where the center is at 0, 0. So if you have x minus h squared plus y minus k squared equals r squared, then your h is or this is the centers at the origin, so your hk is 0, 0, and your radius is 1. So you plug your hk in and your radius, and you notice that you have x squared plus y squared equals 1. So that's the equation of the unit circle. Alright, let's write the standard form of the equation of a circle with a radius of 5 and a center negative 3, 6. You immediately want to say, okay, there's my center given, negative 3, 6, and you also notice that your radius is 5. So you just note that, and then go ahead and plug in HK and R into the standard form. So your H is negative 3, so you have x minus negative 3 squared. You have your k is 6. You have your radius, which is 5. So you have x plus 3 squared plus y minus 6 squared equals 25. And there's your standard form of the equation of a circle for this circle. Okay. Now, what if you were graphing the equation? Here in this case, it's given to you. If you were graphing it, I would go ahead and write that standard form right below it so you can identify your h, k, and r. Now notice it's x plus 3. So what would your h be? Well, you might want to think about that as x minus negative 3. Isn't x minus negative 3 the same thing as x plus 3? So your h follows the minus, x minus negative 3. So your h is actually negative 3. Your k, y minus 2, so it's y minus k, so your k is 2 there. There's your hk center. There's your center of the circle. And if you notice, your r squared is 16. So you square root both sides, you get plus minus 4. Of course, it's a distance, so it can only be 4. Positive length there. So now we have it. Negative 3, 2 is the center of the circle, and we've got a radius of 4. So I'm going to count 1, 2, 3, and 4 away. There's the right-hand side of this circle. I'm going to count 1, 2, 3, 4 up. So 1, 2, 3, 4 up. There's the top of it right there. I'm going to count to the left. 1, 2, 3, 4. There's the left-hand side. I'm going to count down 1, 2, 3, and 4. And there's the bottom. And then I draw that. So I've got this radius of 4 there. Okay, here's a better picture of that. Got the point negative 3, 2. You got a radius of 4. Notice those 4 points shown perfectly to the right horizontal, perfectly up vertical, and so on. Alright, so if you've got x plus 3 quantity squared plus y minus 2 quantity squared equals 16, find the intercepts, if any, of its graph. Well, if you remember when we found intercepts, To find x-intercepts, we let y be 0. To find y-intercepts, we have to let x be 0. So let's go ahead and find our x-intercepts first by letting y be 0 and solving. So we're going to let y be 0. Oops, that's a plus right there. Y be 0. We're going to solve this thing. Notice we have 0 minus 2 is a negative 2. Negative 2 squared is 4. Subtract 4 from both sides. And we've got 12. Square root both sides. We got x plus 3 equals plus or minus, and the square root of 12. 12 is 4 times 3. We know the square root of 4 is 2. So we have x plus 3 equals plus minus 2 root 3. Subtract 3 on both sides. Let me take that up here. Subtract 3 on both sides. I have negative 3 plus minus 2 root 3. And that's my x-intercept. So on your graph, you would have, and this is, if you don't want to think about, if you don't have a calculator on you, that's square root of 12 right there. So you've got two x-intercepts here. You got negative 3 plus root 12, and root 12 is between 3 and 4. So it's 3 point something. So you got negative 3 plus 3 point something, so you're at about right here, 0.5-ish. Okay, there's negative 3 plus root 12. That's negative 3 plus root 12, comma 0, comma, go back. Go back. And there's that point, and then you got negative 3 minus root 12. So you got negative 3 minus 3 point something, so negative 6 point something, about right there. Okay, on this circle. Okay, and then you can find your y-intercept this time by letting x be 0. Let me erase this here. So this time we're going to let our, we just found our x-intercepts, we're going to find our y-intercepts by letting x be 0. So if x is 0, now we got 3 squared, which is 9, so I subtract 9 from both sides. I got y minus 2 squared equals 7. So y minus 2 equals plus or minus root 7. Add 2 to both sides, so I got 2 plus minus root 7. So root 7 is between 2 and 3, a little closer to 3, so 2 point something. So I got 2 plus 2 point something, so I got 4 point something, about right there. So, and then I got 2 minus 2 point something, about right there. And our x-intercept is about right there. Our other x-intercept, about right there. And of course, this was at the point negative 3, 2. This was with a radius of 4. But anyways, you can kind of see your crossing your x and y-intercepts there. Alright, that brings us to the general form. Here's the general form of the equation of a circle. Not the friendliest form, but we can work with it here. So let's see how we can work with this general form here. So what you want to do when you're given general form, if you're asked to graph, is you want to get it into your standard form. Okay, so this is where we're trying to get to on this. So what you're going to do is you're going to put your 4x, put your x's together, leave a little space, put your y's together, and then take that 12 over to the other side. So subtract 12 on both sides. So you got negative 12 right there. Okay, so we got x squared plus 4x plus y squared minus 6y equals negative 12. Okay. Now what you're going to have to do is you're going to have to complete the square. So the question is, what's the number we need right there to make this into a perfect square? And what we did when we completed the square, if you remember, is you took your b term, you take that 4, you take the b and you divide it by 2 and you square it. So I take the 4 over 2 and I square it. So 4 divided by 2, 2 squared is 4. So 4 is the number that I need right there. So I have x squared plus 4x plus 4. Now over here, I'm going to do the same thing with this negative 6 over here. And I should say, if I'm going to add 4 right here to this side, I got to add 4 to this side. So make sure you add 4 over here as well. Okay. Now we complete the square with the y. So I got y squared minus 6y. So I'm going to take that negative 6 right there. That's my b term, if you will. Take the negative 6 divided by 2 and square it. That's negative 3. Negative 3 squared is 9. So I'm going to add a 9 there, which means I got to add a 9 right there. Okay. And now I'm going to factor this right here. So I got x plus 2 times another x plus 2. I go ahead and I factor that right there. Y minus 3, y minus 3. Over here I got negative 12 plus 4, negative 8 plus 9 is 1. And you notice that gives me my standard form. I write the standard form right below it. Okay, so your h would be negative 2, your k would be 3. So the center of this thing, hk, would be negative 2 comma 3, and your r squared is 1, so square root of 1 is 1. So you got the center of this thing at negative 2, 3, and a radius of 1. So you go right 1, up 1, left 1, down 1, and you draw that little circle. I got a better picture right here. So there it is. You got the point negative 2, 3. Go to the right 1 since your radius is 1. Go up 1 since your radius is 1, and so on. And then draw that little circle. Thanks for watching. We'll see you guys soon.